Welcome everyone. In this video I will talk about method of variation of parameters, and this method is used to find the particular integral or to write the general solution of a linear differential equation. We already have uploaded 3 videos in this series, so in case if you are new to the channel, watch them in the sequential order and do subscribe the channel. So first let us start with a second order linear differential equation, which looks like this: a naught x y double prime a1 x y prime a2 x y is equal to rx, where a naught x is not equal to 0. So how the solution is written? Solution is written as y is equal to cf plus pi. And how to find the cf, that we already know from our previous videos. Basically cf is the solution of corresponding homogeneous linear differential equation. So if the right hand side take 0 and then solve it, what you get is cf. Okay. And how to find the pi? The pi is calculated using this formula, that is minus y1 y2 x by w dx plus y2 y1 x by w dx, where y1 and y2 are two linearly independent solutions. So how do you get the two linearly independent solution? When you write cf, the complementary function, you write the cf as c1 y1 plus c2 y2, and this y1 and y2 are two linearly independent solution. The x here is the right hand side divided by a naught x. So we have the right hand side and we divide it by the a naught x, that is the coefficient of second order differential coefficient, and w is the Wronskian of y1 and y2. We can also write the solution in an alternate form. So basically if we have to write the solution, what we are doing, we are writing the solution as y is equal to cf plus pi. Okay. And this cf actually is nothing but c1 y1 plus c2 y2, and how to get that we already have understood. And what was pi? The pi in the previous page I have written, it was minus y1 y2 x by w dx plus y2 y1 x by w dx, right? This is what we have written here. You can check it: minus y1 y2 x by w dx plus y2 y1 x by w dx. Okay, so for our convenience, what we can do, we can rewrite. So suppose I take this term c1 y1 and this term, and I rewrite like this. So here I write minus y2 x by w dx and plus c1, and I multiply it by y1. So what will I get? I will get c1 y1, that is the first term, and then minus sign is already there, minus y1 multiplied by this integral. Okay. And if I take these two terms, this term and this term, what I will get? I will get plus, and here I will get this integral, that is y1 x by w dx and plus c2 multiplied by y2. So this is also a way to write the general solution, and sometimes they ask questions like this, that if the general solution is written as ax into y1 plus bx into y2, then what is ax and bx? So in this case you can clearly see that this term that I have replaced by the function of x, that is ax, and this term I have replaced by bx. So basically what is ax? The ax will be calculated using the formula, that is minus y2 x by w dx plus c1, and bx is calculated using the formula, that is y1 x by w dx plus c2. Okay. So this is also a way to write the general solution, and sometimes, especially in multiple choice question, they may ask you that what is ax and what is bx if the general solution is written like this. So in that case you don't have to calculate the whole pi, you just remember this result, and it is not a different result, it is actually an alternate way of writing the general solution. Okay. Sometimes one more thing is done, and especially in MCQ, because MCQ has become nowadays the preferred mode of taking the exam. So sometimes they also ask the question like suppose they write that y is equal to ax y1 plus bx y2 is the particular integral. They call this is the particular integral. Then what is ax and what is bx, right? So in that case we need to be careful that if they are saying that this is pi, I repeat it may be confusing. If I am saying that this is the general solution, so in case if general solution is written like ax y1 plus bx y2, your ax will be this and your bx will be this. But in case if the particular integral is written like ax y1 plus bx y2, then in that case what will be ax? In that case ax will remain same. Only thing is that I will write minus y2x by w dx. I will not add the constant of integration, because you can clearly see that when I am adding the constant of integration, that is basically giving me the complementary function part. See, this c1 y1 is the first term of the complementary function, and this c2 y2 is the second term of the complementary function. So basically in the previous page, if I go and I rewrite, they can consider this thing as ax. They will call this as ax, and this thing they will call as means this dx part included, so this they will call as bx. So pi can also be written as and with a minus sign. So when they write this ax into y1 plus bx into y2, again I rewrite for avoiding any confusion, where ax will come with this minus sign also, that is minus y2x by w dx, and this bx will come to be y1x by w dx. I hope you have understood the point that I am trying to highlight, that in case of general solution, if I have to write ax, I will add a constant plus c1 and I will add a constant plus c2 here. But in case if we have to find the pi and they are writing the pi in this form and asking what is ax, so I will not add the constant. Okay. Now let us take a few problems to illustrate this. So they are asking find the general solution. So as we know that how to write the solution is written as y is equal to complementary function plus particular integral. To find the complementary function, we first write the auxiliary equation. So what is the auxiliary equation? Auxiliary equation is m square plus 3m plus 2 is equal to 0, and we need to find the roots. M square plus 2m plus m plus 2 is equal to 0. So this will give me what? This will give me m common, m plus 2, and plus 1 common, m plus 2 is equal to 0. So this will give me m plus 2 into m plus 1 is equal to 0. So this implies m is equal to minus 2 and minus 1. So the complementary function that I will get will be c1 e to the power minus 2x plus c2 e to the power minus x. And this part everyone knows, right, how to write the complementary function. Next part is to find the particular integral, right? So to find the particular integral, what is the formula? The formula is minus y1 y2x by w dx plus y2 y1x by w dx. So I want to save a space, so I will do some calculation in the right hand side. So what is y1 here? I hope you can clearly see that y1 I will consider this term as y1 and this term as y2. You can be taken, I mean it can be taken this as y2 or this as y1. There is no such restriction. But since I have written this term as the first term, I am calling this as y1. So y1 is equal to e to the power minus 2x, and y2 is equal to e to the power minus x. And what is the capital X here? The capital X here is the right hand side, that is 2 e to the power x, and divided by the coefficient of the second order term. Here y double dash is coming, but there is no coefficient, so I can consider it 1 and I can just write 2 e to the power x. What else we need? We need w. So to calculate W, we have the formula, that is y1, y2, y1 dash and y2 dash. So how I will calculate it? Y1 is e to the power minus 2x, y2 is e to the power minus x, and y1 dash, if I differentiate, minus 2 e to the power minus 2x, and if I differentiate it, it is minus e to the power minus x. So if you simplify this term into this term, so I will get minus e to the power minus 3x. The power will be added, minus 2x minus x minus 3x, and this will be multiplied, so this minus and this will become plus, so I will get 2 e to the power minus 3x. So what I will get? The Wronskian I get e to the power minus 3x, right? Because it is a minus sign and it is a plus sign, so it will become e to the power minus 2x. And since these two are linearly independent solution, the Wronskian will always be not equal to 0, right? When you will be solving, you will be writing under this, but since I wanted to save space, I have written like this. Now I am going to calculate the pi. So what is y1 here? Y1 is minus e to the power minus 2x. This minus sign is already there, and e to the power minus 2x. What is y2? Y2 is e to the power minus x, and capital X is 2 times e to the power x divided by w. So w is e to the power minus 3x dx plus y2. So y2 is e to the power minus x. What is y1? E to the power minus 2x into 2 e to the power x, that capital X, and divided by w. So w is again e to the power minus 3x dx. Now we have to integrate it. So e to the let me write it and then I will explain. So you can take this 2 common. So I will take minus 2 e to the power minus 2x. E to the power minus x and e to the power x, this will become e to the power 0, so 1, and e to the power 3x will go into the denominator, so it will become e to the power 3x dx plus e to the power minus x, and here what I will get? E to the power minus 2x and e to the power minus x. So I will get e to the power minus x, and if I take this in the numerator, minus x and plus 3x, so it will be e to the power 2x dx. I hope you got it, and this 2 is also there, so that can be taken constant out. So I hope you got it. If you take it in the numerator, it will become e to the power 3x, so 3x plus x 4x, and minus 2x is 2x, and here you also got this, that this will become 1. So if I simplify, if I integrate, minus 2 e to the power minus 3x, integration of e to the power 3x is e to the power 3x by 3, and plus 2 e to the power minus x, and integration of e to the power 2x is e to the power 2x by 2. So if you simplify, how much you will be, what is the value that you will be getting? Actually it is e to the power minus 2x, so it is minus 2x and 3x, so e to the power x, so minus 2 by 3 e to the power x, and here 2 to cancel, so I will get, let me write it, minus 2 by 3 and minus 2x and 3x, that will give me e to the power x, and here it is minus x and plus 2x, so it will give me e to the power x. So this is actually 1 by 3 e to the power x. Okay, I hope you got it. E to the power x minus 2 by 3 e to the power x, so that will be 1 by 3 e to the power x. Now just let me remove this part, so there is no scope of confusion. So that is e to the power x. Now what is the general solution? General solution is y is equal to CF plus PI. So CF I have got is C1 e to the power minus 2x plus C2 e to the power minus x, and plus the particular integral, that is plus 1 by 3 e to the power x. So this is how we solve it. Finding the particular integral requires a lot of computation, especially the integration. So be sure about the integration, and in case if you have some difficulty, let me know that you are facing difficulty in integration. I will try to guide you that how to do integration as well. Okay. Okay, so let us solve a few more problems. So there is a second problem here. Find the general solution of this. Usually given any problem, if they are not specifying which method to use, then we prefer operator method, but here they have specified that we have to use the method of variation of parameter, and especially for this right hand side, this method will be more suitable. So even though if it is not mentioned in the problem that solve this problem by method of variation of parameter, for this particular problem this should be preferred. Now how to write the solution? Y is equal to CF plus PI, and I will not spend much time about CF, sorry. So what is the auxiliary equation? The auxiliary equation is m square plus 16 is equal to 0. So this will give you two imaginary pair of root, like m is equal to plus minus 4i, right? So what will be the complementary function? I am writing the complementary function here. So complementary function is c1 cos 4x plus c2 sin 4x. If you have difficulty in writing this, watch the previous videos. Now I have to find pi. So to find pi, first of all I need to identify the y1 and y2. So what is y1? Y1 is cos 4x and y2 is sin 4x. And what is the right hand side? That is capital X, that is 32 sec 2x, right, divided by 1, so that will remain 1. We need W, Wronskian, so W of y1 and y2. So y1 is cos 4x, y2 is sin 4x. Derivative of cos 4x is minus 4 sin 4x, and derivative of sin 4x is 4 cos 4x. Okay, so if you do the computation, it will give you 4 cos square 4x and plus 4 sin square 4x. So this will become 1, because cos square 4x plus sin square 4x will be 1, and this is not equal to 0. We know that Wronskian will not be equal to 0 because we are taking two linearly independent solution. Now how to find the pi? So I am going to write the process of finding the pi here. So pi is minus y1. Let me write the formula again. Minus y1 y2 x by w dx plus y2 y1 x by w dx. Okay, so what is minus y1? So it is minus cos 4x. What is y2? Sin 4x, and into the right hand side, that is 32 sec 2x divided by w, that is 4 dx, and plus y2. So y2 is sin 4x and y1 is cos 4x into the right hand side, that is 32 sec 2x divided by 4, and this is dx. Okay, so what it will be, let me write it. So this 4 I can take out and this 32 I can take out. So 32 by 4 will be 8, so I can write minus 8 cos 4x. And where I think it is not sec 2x. Okay, it is 4x and it is sec 2x. Let me check whether it is correct or not. So it is okay, so no problem. So what I am going to get? I am going to get here minus 4, that I already have taken 32 by 8, that is minus 8 common, and here we have the integration, that is sin 4x divided by sec 2x will become cos 2x dx, and plus 32 by 4 will become 8, so 8 sin 4x, and here the integral, that will be cos 4x by sec 2x can be written as cos 2x dx. Now we have to do the integration, and a lot of students will make mistake in the integration, so I will be very slow in the explanation process. Minus 4 cos 4x, there is a result that everyone knows, that sin 2 theta, right, can be written as 2 sin theta into cos theta, right. So here we have sin 4x, so that can be written as 2 sin 2x into cos 2x divided by cos 2x dx, And we also know a result in trigonometry, cos 4x. So you remember that result, cos 2 theta is equal to 2 cos square theta minus 1. Okay, so here this cos 4x term I can write 2 cos square 4x by 2, that is 2x minus 1 by cos 2x dx. Okay, now here this cos 2x and this cos 2x is cancelled, and so what I am getting, minus 8 into 2, so I can write minus 16 cos 4x, and integration of sine 2x, that will be minus cos 2x by 2. I hope you remember the integration of sine x, that is minus cos x, but here the coefficient of x is 2, so I need to divide it by 2, so that is minus cos 2x by 2, and plus here what I get 8 sine 4x, and this integral I have to do. So how I will do this integral, 2 will be constant, so that will be taken out. Integration of cos square 2x, I will separate the term, this by cos 2x and 1 by cos 2x, so the 2 will be constant. Cos square 2x by cos 2x will give me cos 2x dx, and minus 1 by cos 2x will give me sec 2x dx. Okay, since we don't have a space here, so we need to move to the next page. So for our convenience, we already have copied the terms from here on this page, so this is exactly what we have got. Now proceeding forward, what I will get here, so this minus and this minus will become plus, 16 and 2 will cancel, so I will get 8 cos 4x into cos 2x plus 8 sine 4x, and if you look at this integration, this will give me integration of cos 2x is sine 2x by 2, right? And here we have sec of 2x, so I hope you remember the integration of sec of 2x, it is log of mod of sec of 2x plus tan 2x, right? A mod, and since I have to the coefficient is 2, so I need to divide it by 1 by 2, and then the bracket will be closed. Okay, so let us do the simplification further. So here I get 8 cos 4x into cos 2x, this 2 term and this 2 term is cancelled, so I get plus 8 sine 4x into sine 2x, and minus this is 1 by 2 and this is 4, so sorry, this is 8, so 8 and 2 will cancel, I will get 4 sine 4x into log mod of sec 2x plus tan 2x. So this is what we are getting as our pi. So what is the final solution? The final solution will be CF plus pi. So CF is C1 cos 4x plus C2 sin 4x. So let me write the final solution, that is y is equal to C1 cos 4x plus C2 sin 4x plus 8 cos 4x into cos 2x plus 8 sin 4x into sin 2x minus 4 sin 4x log of mod of sec 2x plus tan 2x. So this is our final solution for this particular problem. So we already have done 2 problems. For more confidence, let us solve this third problem, and then I will talk about how to solve third order linear differential equation by the method of variation of parameter. So keep watching, don't leave the things in between. So to solve this third problem, it is given that find the general solution of this linear differential equation where y1 is equal to x and y2 is equal to 1 by x using method of variation of parameter. First thing that I want you to note that this is not a linear differential equation with constant coefficient, but rather with a variable coefficient. So how to solve the linear differential equation with variable coefficient, that will be we will be talking in the coming videos. But here for our convenience, they already have provided us with the two linearly independent solution, that is y1 and y2. So what is this general solution? General solution is CF plus PI, we all know. And we already are given that y1 and y2. So CF will be C1 y1 plus C2 y2. So that will be C1 into x plus C2 into 1 by x. Okay. And so y1 y2 is known to us. What is W? W is y1 y2 y1 dash y2 dash, right? So that will be equal to x 1 by x. Derivative of x is 1 and derivative of 1 by x is minus 1 by x square. So I will get x into minus 1 by x square, that is minus 1 by x minus 1 by x, which is equal to minus 2 by x. And what is capital X? So don't make this mistake here. Capital X is x cube, the right hand side, divided by the coefficient of highest order term, or here it is y double dash, so that is x square, so it is equal to x. So all the ingredient that we require we already have. Now we need to find pi. So pi is minus y1 y2x by w dx plus y2 y1x by w dx. So what it will be, let me write it in this side. So y1 we have got is x, y1 is x, okay. So minus x, what is y2? y2 is 1 by x, and what is capital X? That is a small x, so that I have got x here. And what is w? So w I have got minus 2 by x dx, and plus what is y2? So y2 is 1 by x. What is y1? So y1 is x. What is capital X? So that is also x by minus 2 by x dx. Okay, continuing in this side here, let me simplify that this x and this x is cancel. This is a minus sign and this is a minus sign, so it will become plus sign. So I will get x, and if I take it into the numerator, it will become x by 2 dx. And here it is minus and it is plus, so this will be a minus term. This x into x, right? So it will become x square, and then this x, if you take in the numerator, it will become x cube. So I will have minus 1 by x. Rather 2 will also be taken out as a constant, so I can write minus 1 by 2x, and here I will have x cube dx. Okay, so solving further, this x by 2 and integration of x will give me x square by 2, and minus 1 by 2 into x, and integration of x cube will give me x to the power 4 by 4. So if I simplify it, I will get what? X into x square, that is x cube by 4, and minus x4 by x, so this will become minus x cube by 8. So in the end I will get x cube by 8, right? I hope you got it. X cube by 4 minus x cube by 8 is x cube by 8. So what is the general solution in this case? The general solution in this case is the complementary function, that is c1 y1. I should write it in terms of the given function. So c1, and what is y1 here? So y1 here is actually x, so c1 x plus c2 into 1 by x, and plus the particular integral, that is 1 by 8 x cube. So this is how we can solve a second order linear differential equation using the method of variation of parameter. Okay, now what we are going to talk about is that how to solve a third order linear differential equation by method of variation of parameter. Actually this can be extended to any order, but we are not going into the higher order detail, or just to avoid the complexity I am going to be very precise in my argument, right? So let us solve a problem for third order, but before we solve the problem, let us understand the process. One thing that I hope you already have noted, that this method is applicable for both constant coefficient and variable coefficient problem, right? So now suppose I take a linear differential equation of third order, y triple dash, y double dash, y dash, and y is equal to rx, a naught x is not equal to 0. And suppose its complementary function is written as a into y1x plus b into y2x plus c into y3x, where y1, y2 and y3 are linearly independent solution. Because it is a third order linear differential equation, it will have three linearly independent solution, right? And a, b and c that are arbitrary constant, right? So once we write this as the complementary function, to find the particular integral, what is the process? So here we actually directly write the general solution. We write the general solution as y is equal to ax into y1x plus bx into y2x plus cx into y3x. And it is not a different way, like in the second order also I was writing the solution like what, ax into y1 plus bx into y2. But while doing the problem solving, I was calculating the pi separately, right? But here we are going to look at the general solution like this: ax into y1x plus bx into y2x plus cx into y3x. And how to get this ax, bx and cx, because y1x, y2x and y3x we already know. So to determine this, we are going to use these three equations, and these three equations are what: a dash x y1, b dash x y2, c dash x y3, then a dash x y1 dash, a b dash x y2 dash, c dash x y3 dash, and you can see a dash x y1 double dash, b dash x y2 double dash, and c dash x y3 double dash, which is equal to the rx by a naught x, that is the right hand side divided by the coefficient of highest order term gx, right? So that I am calling gx. So I hope it is clear. Now this is a system of equation, and this system of equation we need to solve by the Cramer's rule. So to make sense of what I just have discussed, I am going to solve this problem, and listen this very carefully, because Cramer's rule, I think most of you might be aware. If you are not aware, still you can follow, and in the process also I will be explaining some details related to the Cramer's rule as well. So we have a third order linear differential equation, and if I have to solve it, first of all I am going to write the complementary function. So to write the complementary function, what is the auxiliary equation? The auxiliary equation is m cube minus 6m square plus 11m minus 6 is equal to 0. And I am not going to write the details. It is a third cubic equation, and you can find its root very easily. So it will be m is equal to 1, 2 and 3. Okay. Now what will be the complementary function? Complementary function will be c1 e to the power x plus c2 e to the power 2x plus c3 e to the power 3x. So basically what we have got y1 is equal to e to the power x, y2 is equal to e to the power 2x, and y3 is equal to e to the power 3x. It is y1x also we can write, because these are all functions of x. Now to solve it by the method of variation of parameter, we assume the solution. So the solution is, or the general solution is, I am writing the solution is y is equal to ax, that I have to find y1, so e to the power x, plus bx, that we have to find, and y2, that is e to the power 2x, plus cx, and e to the power 3x, y3x. Okay. Now rx we already know, that is e to the power minus x, right? So if you want to write it, you can write, but there is no need. So these three equations that we have to write, just quickly see that how it is written. We write a dash x. So a dash x is constant in all this. B dash x is also constant and c dash x is constant. Here we write y1, y1 dash, y1 double dash, y2, y2 dash, y2 double dash, y3, y3 dash and y3 double dash. So I'm not going to rewrite. I'm directly going to write the expressions here. So I'm writing a dash, or before I write that, let me also make one comment. So the equations to determine ax that we want to get, bx and cx are as follows, and this is how you have to write. So you write a dash x, right? A dash x, and then what you write? Y1 dash, y1, just a dash x and then y1. So a dash x e to the power x, b dash x, y2 that is e to the power 2x, and a dash c dash x, and then y3 that is e to the power 3x, that is equal to 0, right? I could have just written a dash b dash also, because that will keep our expression neat or clean. So if we already understand that we are basically looking for a, b and c, which are the functions of x. So for our convenience, so that it does not look very clumsy, I am writing it directly a dash e to the power x plus b dash e to the power 2x plus c dash e to the power 3x. And I hope you are clear that by a dash I means the function of x. What will be the second equation? I have to differentiate. This is y1, this is y2, this is y3. So a dash, y dash. So a dash and derivative of e to the power x is e to the power x, plus derivative of e to the power 2x is 2 e to the power 2x. So it will become 2b dash e to the power 2x, plus it will become 3c dash e to the power 3x, and this is also equal to 0. And then we differentiate it again, so it will remain same, a dash e to the power x. It will become 4b dash e to the power 2x, and it will be 9c dash e to the power 3x, and that is equal to gx, that is the right hand side divided by the highest order coefficient. So it is equal to e to the power minus x. I hope you remember this. This is what I have to write, rx by a naught x. Now these are the three equations that we have to solve. So to solve it, we are going to use the Cramer's rule. And how the Cramer's rule work? So in Cramer's rule, first we calculate something known as delta, if you remember. And how the delta is calculated? Delta is calculated by actually what we are solving for? We are solving for getting the value of a dash, b dash and c dash. So these are our variables here. So we are solving it for a dash, b dash and c dash. So the process tells you, I'm just taking some time to explain the process because some of you might not be aware. So the process is, first write you delta, and here actually that delta will be the Wronskian. So I am and how the Wronskian is written, so I am writing here w. So w that is written is, we just take the coefficient of the variable that we want to calculate. I again repeat, we are solving this three system of equation, or this system of equation which has three equations, to get the value of a dash, b dash and c dash, which are basically the functions of x. So I write the coefficient of a dash in the first column, so that will be e to the power x, e to the power x, e to the power x. Then I write the coefficient of b dash, that is e to the power 2x, 2 e to the power 2x and 4 e to the power 2x. And then coefficient of c dash, that is e to the power 3x, 3 e to the power 3x and 9 e to the power 3x. So this is what we are getting. So this is basically the determinant which we have got by solving, by writing the coefficient of a dash in the first column, coefficient of b dash in the second column and coefficient of c dash in the third column. So from the first column you can take e to the power x common, from the second column e to the power 2x common, and from the third column e to the power 3x common. So e to the power x into e to the power 2x into e to the power 3x will become e to the power 6x. I hope you know that from a determinant we can take the common from first column, second column, and third column. So what I will get is 1 1 1 1 2 4 and sorry, this is also 1, so 1 and 3 and 9, so 1 3 and 9. So if you expand it, what you will get, e to the power 6x, and should I write it directly, 1 into 9 into 2 18 minus 12, so 9 2 into 9 18 and 4 into 3 12, so 18 minus 12 is 6, and then minus 9 minus 3, 1 9 minus 3 is equal to 6, and plus 1, that is 4 minus 2, so 4 minus 2 is how much, 2. So we get this 6 and 6 cancel, so what we get is 2 e to the power 6x. So that is actually the delta value, which is nothing but the Wronskian for the value of y1, y2 and y3, right? Now what we do, we get something like in Kramer's rule, we solve something like x into delta. And what is x into delta? So here let me go to the next page, and what I am saying is that now I am going to solve it for delta into a dash, delta into a dash. And what is delta into a dash? You actually replace in this delta the first column, because a dash is coming as the coefficient of ex, so this column will be replaced by the right hand side. So the right hand side is 0 0 and e to the power minus x, and other two columns will remain same, other two columns will remain same. So other two columns are e to the power 2x, 2 e to the power 2x and 4 e to the power 2x, and here you will have e to the power 3x, 3 e to the power 3x and 9 e to the power 3x. I hope you got what I did. I am actually solving it for w, that is Wronskian, into a dash, because we are solving it to get the value of a dash. So in the Wronskian value, I have replaced the first column by the right hand side, and if you simplify it, what you will get, you just need to expand it about the first column. So if you expand it about the first column, 0 0 and then e to the power minus x, this column gone, this row gone, so 3 into 2, so let me write it, I will get 3 into e to the power 5x and minus 2 into e to the power 5x. So it is equal to how much? It is e to the power 5x into e to the power minus x. So what I will get is e to the power 4x. And so w, so this implies w a dash is equal to e to the power 4x. And what I got as w I got as 2 e to the power 6x. So I will write 2 e to the power 6x into a dash is equal to e to the power 4x. So what is a dash? A dash is 1 by 2, and if I divide it by e to the power 4x, I will get e to the power minus 2x. But what is a dash? A dash is the differential coefficient of a with respect to x. I hope you are clear that by dash we mean the differential coefficient. So basically, if I have to get a, what I will do, if I have a dash is the derivative, and derivative is this, so if I want to get a, I have to integrate. So if I integrate a dash, I will get a, right, because if I differentiate a, I get a dash. So if I integrate a dash, I will get a, and if I integrate this, it is 1 by 2 integration of e to the power minus 2x dx plus constant of integration. So what I got the first thing, that is ax is equal to integration of e to the power minus 2x will be e to the power minus 2x by 2, and 2 is already there, so it will become minus 1 by 4 e to the power 2x dx plus c1. So this is how I got the first function ax. Now I will solve it to get the wb dash. So wb dash, how will you get? The first row will remain same, sorry, first column, e to the power x, e to the power x, e to the power x. Second column, because now we are solving it for wb dash, will be replaced by the right hand side. So 0 0 e to the power minus x, e to the power 3x, 3 e to the power 3x and 9 e to the power 3x. So if you simplify this, again I can expand it about the second column, right? So it will be like what it will be. This is coming in second row, third row and second column. So you can I hope you remember plus minus plus plus minus plus plus minus. So basically it is minus e to the power minus x. This column gone, this row gone. So what it will be, e to the power x into 9 e to the power x. So 9 e to the power 4x, and minus e to the power x and 3 e to the power x. So it will be minus e to the power 4x. So 9 minus e, so 8, and this is minus, so minus 8 and e to the power 3x. I hope you are getting what I have done. Okay, so is it clear up to this or any doubt? I think there is a small mistake that I made. Let me correct it. I'm expanding it about the second column, right? So this element is coming in third row and second column. So minus e to the power minus x. I hope you understand why I'm writing minus. So this row will be gone and this column will be gone. So e to the power x into 3 e to the power x. So basically it will be 3 e to the power 4x, and e to the power x into e to the power 3x. So e to the power 4x. So what I will get is not 8 but minus 2 e to the power 3x. Okay, so sorry for this mistake. So I write minus 2 e to the power 3x. Okay, so what is b dash? So I now can write b dash directly. So b dash is minus 2 e to the power 3x by w. So w we have got in the previous page, 2 e to the power 6x. So I write 2 e to the power 6x. So that we got like b dash is equal to 2 to cancel minus e to the power minus 3x. Okay, so if I have to get b, I have to integrate it because b dash is the derivative of b. So to get b we have to integrate. So b will be equal to minus integration of e to the power minus 3x is e to the power minus 3x by minus 3 plus constant of integration, that is c2. So we have got bx also. Bx we are getting, this will become plus. So 1 by 3 e to the power minus 3x plus c2. Since we don't have a space here, so now we are going to move to the next page. So the next thing that we have to calculate is WC dash. Okay, so how the WC dash will be written? WC dash will be written as I have to replace the third column. So first column of W was e to the power x, e to the power x, e to the power x, e to the power 2x, 2 e to the power 2x, and 4 e to the power 2x. I hope you remember. And third column, which is like this one, it will be replaced by the right hand side, that is 0 0 e to the power minus x. So I write 0 0 e to the power minus x. In case if you still have doubt that how the Cramer's rule works, I will suggest you that please understand the Cramer's rule. I have tried, so I hope you have got. Let me explain quickly again that we have a system. We first write delta, and how do we write delta? Actually this delta actually here is w, because we take the coefficient of a dash, b dash and c dash. So we calculated determinant value. Next we calculate the thing that we want to get, like we calculate, we are solving this for getting a dash, b dash, c dash. So we are calculating w a dash, and to calculate w a dash we are replacing the first column by the right hand side. Then we are calculating w b dash. So to calculate w b dash we are replacing the second column by the right hand side, and then we are calculating w c dash. So to calculate w c dash we are replacing the third column by the right hand side. So once we get w c dash, we can solve it for c dash. So what is this? Now I can expand it about the third column. So third column is this element is coming in the third row and third column. So it will be e to the power minus x, and then ex into 2ex. So 2 e to the power 3x and minus e to the power 3x. Okay, so e to the power minus x and e to the power how much, 3x. So what we got? We got e to the power 2x. So So wc dash is e to the power 2x. So this implies that c dash is equal to e to the power 2x by w. W we have calculated is 2 e to the power 6x. I hope you remember. So this is equal to 1 by 2 e to the power minus 4x. So we have c dash is equal to 1 by 2 e to the power minus 4x. So to get c dash, what we have to do? We have to integrate both sides, right? C dash is basically what? C dash is d by dx of cx, the function of x. So if I have to get c, I have to integrate. So if I integrate, I will get c, and here I will get 1 by 2 e to the power minus 4x by minus 4 plus constant of integration, let me call it c3. So the capital C or cx we are getting is minus 1 by 8 e to the power minus 4x plus c3. So now what will be the general solution? As I have told you earlier, the general solution I was writing is ax into y1, which was e to the power x, plus bx into y2, which was e to the power 2x, plus cx into y3, which was e to the power 3x. And what is ax that I have got? Ax I have got is where is ax? Yeah, minus 1 by 4 e to the power 2x dx. Oh, why I have written dx here? Sorry, dx when once I integrated, and some mistake also I have made when I did a cross check. This, first of all, this dx would not be there. Second is 1 by 4 e to the power minus 2x. So this is minus 2x. Okay, so here we have ax is minus 1 by 4 e to the power minus 2x plus constant of integration c1 e to the power x. And what is bx that I have got? Bx I have got 1 by 3 e to the power minus 3x. So 1 by 3 e to the power minus 3x plus c2 e to the power 2x. And what is cx I have got? Minus 1 by 8 e to the power minus 4x plus c3 e to the power 3x. I hope up to this there is no doubt or confusion. So moving ahead, let me simplify this. So what we get? Y is equal to c1 e to the power x. Let us collect the constant term first. c2 e to the power 2x from the second bracket, c2 e to the power 2x, and from the third bracket I will get c3 e to the power 3x. So basically this is the complementary function part. Now if you look at this term, I will get minus, let me write it. So minus 1 by 4 e to the power minus 2x and x, I will get e to the power minus x. From here I get minus, not minus, plus 1 by 3 e to the power minus 3x and 2x, it will be e to the power minus x. And from here I will get minus 1 by 8 e to the power minus x. So if I simplify, what it will be? Can we do the simplification? So we have minus 1 by 4 plus 1 by 3 and minus 1 by 8. So the LCM will be 24, it will be minus 6, it will be plus 8, and it will be minus 3. So minus 9 plus 8 means minus 1 by 24. So we can write the final solution like y is equal to c1 e to the power x plus c2 e to the power 2x plus c3 e to the power 3x minus 1 by 24 e to the power minus x. Okay, so this is how you can solve a third order linear differential equation with the help of method of variation of parameter. I repeat the whole thing quickly so that you don't get any there is no confusion. So first of all, given any third order linear differential equation, we write the auxiliary equation, we get the roots, and then we write the complementary function c1 e to the power x, c2 e to the power 2x, c3 e to the power 3x. Or basically if you don't want to write it, you can also directly write that because of the roots are like 1, 2 or 3, you will have y1 is equal to e to the power x, y2 will be e to the power 2x, and y3 will be e to the power 3x. But it is better so that you are not confused to write the CF also. Once we write this, these three equations you have to keep in mind, and it is not very difficult to remember them. It is a dash and y1, a dash y1, b dash y2, c dash y3, then a dash y1 dash, b dash y2 dash c dash y3 dash and a dash y1 double dash b dash y2 double dash c dash y3 double dash. This is what you have to remember, this result, here. So a dash x will remain same, b dash x will remain same, c dash x will remain same, and y1 y2 y3. So you just can even visualize it like you are going to get the Wronskian if you write these terms as the determinant. So now you get the w value. W, how do you get w? You just write the coefficient of a dash as the first column, coefficient of b dash as the second, coefficient of c dash as the third column, and then you calculate this determinant. Next step, you solve w a dash. How do you get w a dash? Replace the first column by the right hand side, solve this determinant, and then solve it for a dash, and once you solve it for a dash, you integrate it to get the value of ax. Here I made a mistake in the beginning, but I have corrected it in the latter, that e to the power minus 2x will be e to the power minus 2x by 2. Similarly, you get w b dash, and once you get w b dash, you can get a b dash you get, and then you integrate it to get the v, and finally you solve it for w c dash, and then you solve it for c dash. Sorry, here also, yeah, we already have integrated. So you solve it for c dash, and then you integrate to get the value of c, which is nothing but a function of x, and then you write the solution as ax into y1, bx into y2, and cx into y3. You get the value of ax, bx, and cx, and then you simplify the terms. What you get is the final solution. So in this video I talked about method of variation of parameter, and I hope you have understood it. In case if you have understood, like the video and share with all your friends. I am going to upload next videos like method of undetermined coefficient and Euler-Cauchy. I will complete the playlist, and someone was also putting a comment to upload a video for more problems on operator method, so I will try to do that as well. That's all in this video. Thanks for watching and have a very great day.